Okay, so thank you for joining me. This is Geography 132, Geography of World Regions, and I'm Professor Wade Renando. I'm an adjunct professor at Jackson College. I've been teaching there for about 8 years. This is one of my favorite classes and the first one I taught. I went to Alma College and studied history and political science, and then went to St. Cloud State and studied geography. This lecture will be about an hour or so. If you want, you can send a text question at any time. You're welcome to ask a question if you have a microphone, but if you are not using it, please hit mute to keep it a little bit quieter. So we are going to talk about the first three chapters, which is basically concepts of geography, mapping, and also the first chapter of the regions North America. So geography matters. This class talks about physical geography as well as human geography. One second here. Physical geography and human geography. And we'll talk about thematic systems of geography and regional geography. Thematic map is usually a map about a specific theme, usually kind of one topic. And then regional maps are maps that kind of cover a large area. The picture here is of a settlement in the Amazon basin. And that's just kind of a picture of a woman in a rural village in the Amazon. So one thing we'll talk about is aerial differentiation. It's basically when you have a photograph from space, often you'll be able to see there are significant differences. This air photo is of the US-Mexican border. And on the top left, you'll see the US side. On the bottom right, you see the Mexican side. And you can tell from space that in the American side, they have a more large, more effective mechanized farming. And then on the southern part of it, south of Mexico, you see there are smaller plots of land that probably aren't as efficient. They don't have tractors and so on. So even from space, you can often see red is vegetation and farming in this particular picture. Even from space, you can see that there are significant differences in farming and other things throughout different parts of the world, even if they're very close to each other. So this here is interesting. This is a picture of Florence, Italy at the same scale as an Atlanta interchange in Atlanta, Georgia. And Florence, Italy is a medieval city of about 400,000 people. And Atlanta is also a large sprawling city of about 450,000, but it takes up much more space because it's very car centric. And you can see here there are a lot more people living in Florence on the left than in this interchange in Atlanta on the right, which is has a couple freeways and some office parks and so on, but it's kind of very sprawling, car centric, and not very densely populated. So if you were to take a closer look at Florence, Italy, this is what it looks like. It's 361,000, so fairly large city, pretty old, very walkable. Much of it was built in the Middle Ages. And you can kind of see there are lots of beautiful buildings from the medieval periods and Baroque and Renaissance and so on. And it's very walkable because it was built before cars. And that's how many cities were built around the world until the 20th century, especially the mid 20th century when sprawl and cities became more car centric. So we'll talk a little bit more about that when we talk about North America. So geographers use tools like locations, maps, remote sensing, and GIS. This is a diagram of the Earth, and this basically shows latitude and longitude. The prime meridian is the line of longitude that counts as basically the center point where everything to the east of it is considered the eastern hemisphere, everything to the west is the western hemisphere. And the prime meridian and all lines of longitude are great circles, meaning they divide the Earth into two even parts. The only line of latitude that's a great circle is the equator, which is right in the middle and divides the Earth into northern and southern hemispheres. So lines of latitude run east-west but measure north-south, and they are parallel to each other, while lines of longitude run north-south but measure east-west, and they converge at the northern and southern poles. So they are not parallel with each other. They're closer to each other in the northern and southern hemisphere towards the poles, and then they're further more spread apart along the equator, as you can see here. So this grid system is used a lot in navigation. Nowadays, people will often use digital degrees of latitude and longitude. So Jackson, Michigan might be about 42.8184 degrees north, and then I think 80 something west. And that's a common way of measuring where you are in the world now, using latitude and longitude and digital degrees. So here we have some map projections. We'll talk about map projections, map scales, and basic map concepts. The map on the left is a map that's fairly well known. It's using something called the Mercator projection. And Mercator was a Flemish cartographer who lived in the 1500s, who created very accurate maps of the world for the time in the 1500s by collecting information other people had collected. And he developed a map using the Mercator projection that was designed to keep the proper shape of land masses in the Northern Hemisphere. It was often used for sailing. So one of the most important things was to get an accurate idea of what different land masses were. So Greenland in reality is about as large as Mexico, but this particular projection vastly increases the size of things in the very northern and southern part of the map. So Antarctica looks huge, even though it's a little larger than Australia, and Greenland looks huge, even though it's about the same size as Mexico. So Africa and South America are much larger than they appear on this map, but this is a map that's still fairly commonly used, even though it distorts the size of land masses near the poles. The one on the right is a Robinson projection. This is something that's occasionally used by National Geographic, and it looks to try to get a more balanced view of balancing the proper size and shape. And as you can see, Africa and South America are a little larger, but Greenland gets a little distorted when you get towards the poles. So there's no perfect projection. They're just trade-offs no matter what ones you're kind of trying to work with. So one second here. Okay, here's another picture of the Mercator projection. This is still often used by Google Maps. And then there's another projection developed by a person named Peters. This is the Peters projection developed in the 1960s and 70s. And this does accurately show the size of Africa and South America. But as you can see, it's not perfect either because the land in the very northern and southern parts get kind of squashed and distorted. So this is a map that's trying to keep the proper size, but then it distorts some of the shapes near the northern and southern poles. This here is, again, Robinson projection. This is a fairly common projection that's a good compromise of keeping the proper size and the proper shape of different land masses. And then this is something that's a modified version of the Robinson projection called the Winkel-Trapel projection. This has the lines of latitude bend away towards the edge of the map, and that minimizes some of the distortion. But that's not accurate either, because in real life, lines of latitude are parallel to each other. They don't curve away from each other. So although this does better preserve some of the shapes of the land masses, it creates the impression that lines of latitude bend away from each other when they don't. And this is what's called an interrupted map. An interrupted map is when you kind of break up the map into different parts, as if you were kind of trying to peel an orange and you broke it up into different parts. And this does a better job preserving the shape of all the different land masses, but it creates the impression that there are these gaps in the Earth, and Antarctica is 4 different land masses, which isn't accurate either. But it's a pretty good projection as well. So scale in maps is an important concept. You'll hear something that's a large scale map or a small scale map, and scale is relative to other maps. So the map on the left covers a broader area, but in less detail. So that's actually a small scale map compared to the map on the right, which is enlarged. So objects appear larger in a large scale map and smaller in a small scale map. So this part over here, where you can see the roads and more information, would be a large scale map when compared to the map on the left. A map of Jackson County would be a large scale map compared to a map of Michigan that's the same size. A map of Michigan would be a large scale compared to a map of the world that's the same size. So scale is important. Most scales have a bar that says what the scale is. Here, 1 inch roughly equals 2 miles. Here, 1 inch roughly equals about 1,000 feet. So this is about 4 to 5 times larger in scale than this one here. But most maps will say how large the representation is on a map, and objects appear larger in large scale maps and smaller in small scale maps. So this is a choropleth map, or a thematic map. This map shows the population density of India. India recently surpassed China as the largest country in the world population-wise. It has about 1.4 billion people. They had a very high birth rate, meaning they used to have lots of children born per woman. Now that's actually come down due to better health care, more people living in cities, more educated women, better access to birth control and other things. So now the birth rate is about 2.3 children born to each woman roughly the age of 15 to 45, which is down significantly. So they have been growing, but the rate of growth has slowed somewhat in India, and it's slowed significantly in China because of their one-child policy. You can see here that there's a much greater population density in the northern part. That's because they have the Yangtze River and they have very good farmland here. So because you can grow food almost year round and there's reliable water from different rivers in this area of the world, along with eastern China and a few others, have very high population densities. This here is kind of a fun map. This is a map of NFL fans. This is from 2014. I've been trying to find a more current one, but I haven't been able to. But basically, Facebook collects information, and this is broken down by county. And whatever football team gets the most likes on Facebook within a certain county, they are given that team's colors. So the Lions, unsurprisingly, are popular without almost all the Lower Peninsula, and then a tiny portion of the southwest part are Bears fans, even though they're closer to Chicago than the Lions. So I guess a tiny group are Bears fans. In the UP, it's about evenly divided between Packers and Lions fans. Almost all of the UP is a lot closer to Green Bay. Green Bay is about here. So you can't blame people for being Packers fans, but most are Lions fans throughout Michigan. And then you can see some of them are kind of interesting. Some of them are real interesting. Iowa has no football team, so you have some Vikings, some Packers, some Bears, some Chiefs, a little bit of everything there. And then for some reason, the Cowboys were popular in Nevada. Now they have their own football team, the Raiders. So I'm guessing that the Raiders have supplanted the Cowboys as the most popular team there. And then Alaska likes the Seahawks. I guess they're closer to Seattle than anyone else. And then I think I can't tell who Hawaii likes. 49ers. Yeah, I guess that makes sense. They're as close to them as anyone. But that's a really interesting map of who different places like for football teams. This is a map of Australia with Australia on the top. Most maps have north on the top, but that's a tradition. There's no rule or law saying it has to be that way. But this is a map that imagines Australia is at the top of the map instead of the land down under. Technically, it is accurate. There's nothing wrong or off about this. It's just not how we're used to seeing the world, having south on the top where Australia is and then everyone else on the bottom. So another feature in geography is geographic information systems, and this is something that I work with a lot. Geographic information systems, or GIS, are computerized systems of analyzing geography and working with different layers of data. So in this diagram here, it imagines that you have a grid survey layer, like townships and ranges, placed over a zoning layer, placed over floodplains or wetlands or land covers, soils, survey control points, and a final map that concludes with all of those different things on one map. Parcels are very common in GIS. I work a lot with parcels. And GIS basically uses different layers of data that you can kind of turn on and off or add to maps depending on what you need. And it's a very good, important tool for analysis and planning, and it's used in many different kinds of purposes. So the first two chapters talk about basic mapping concepts and then kind of global environmental issues. Then starting with chapter 3, North America, we're going to break it down by region. So we're working on North America now. Latin America started today. We won't be able to cover the Caribbean because we just don't have enough time, and we won't also be able to cover Oceania. But then we'll cover North America, the Middle East, Sub-Saharan Africa, Europe, Southeast Asia, East Asia, so on and so forth. So those are the different regions that we'll talk about in our class. So in addition to physical geography, demographic information, human geography is an important part of geography in general and this class. On here we have what are called population pyramids. These are diagrams that break down a country's population or city or state into different genders and age groups. And as you can see on the left, this is rapid growth. Nigeria has a very large population below the age of 5. This is percent of total population. So about 17% of the population of Nigeria is below 5 years old. And you can see here, if you compare that to the United States, the population below 5 is about 3.5 for boys and girls. So the population is about 7 million compared to 17 as a percentage. And then in Germany and Japan and Korea and Italy, they've had very low birth rates for a while, so they have a larger older population and a much smaller base, so because they have a lot fewer young children. In Japan and South Korea, this is becoming a major problem. Their populations are projected to drop significantly starting very soon. In fact, Japan's population is already declining because of the very low birth rates. So this can change if a country becomes more urban. Women in big cities almost always have fewer kids than women in rural areas. So if urbanization happens in Nigeria, this could change, and maybe the population of younger people would narrow, and then older people would increase. But it can vary significantly from country to country what the population pyramid and demographics are. So population growth and change, this graph kind of shows the different patterns for growth within a society, could be the world or a country. For a very long time, there was very little population growth in the world because death rates were similar to birth rates before vaccines and reliable water and healthy food and a lot of the health that we now have and healthcare we now have. The world's population was fairly flat because death rates and birth rates were about the same, high birth rate, high death rate. And then starting around the 1800s with the Industrial Revolution, the world transitioned from pre-industrial to transitional. And that is when the world's population or a country's population starts growing rapidly because people are having the same amount of kids, but the kids are living longer because of better healthcare, better food, better nutrition. So this is when you often have a very high growth rate within the world or a country during this stage 2 transitional. Stage 3 transitional is when the birth rates start to decline. People know that if they have a kid, they're likely to live to adulthood. So you still have a population going up, but you start seeing birth rates declining. And then you have stage 4, where you have usually low birth rates and low growth rates. And that might describe the US. We have a relatively slow population growth, mostly because of immigration. If it wasn't for immigration, we'd probably have a declining population. But then you have something that's relatively new, and that's stage 5, post-industrial. This would describe Italy or Germany or Japan or Korea, where you actually have a rapidly aging population and a smaller percentage of young people, people having fewer kids, and potentially even crashing birth rates and even maybe a crashing population. So post-industrial stage 5 is fairly new. It was almost unheard of till about 20 or 30 years ago. So now there are many countries that are in stages 3 and 4 and 5. Nigeria would be in stage 3. Japan and Korea would be in stage 5. The US would be kind of on the edge of 4 and 5. But that's kind of different stages of population growth in a society. So here's a picture of world population density. And you can see here it's not evenly distributed. About half of the world's population lives in China, Japan, Indonesia, and India, this little area here. Let me see if I can circle that. I'm going to try to use a pen. Nope, it's not drawing. I'll try one more time. Highlighter. Nope, oh well. Anyway, this area, you can clearly see where you have the deep purple spots. That's a high population in eastern China, northern India, Java, which is the island in Indonesia, that's very dark red, where Jakarta is, the Philippines and Japan. And that area contains over half the world's population, even though it's fairly small. Here's a view of plate tectonics. This is a major part of physical geography. And here you have some of the major Earth plates that move back and forth. They move about the same speed as your fingernail grows. So in the Atlantic, there's the Mid-Atlantic Ridge, where you have a divergent plate boundary, where you have the North American plate and the African plate and South American plate both pushing away from each other. So the Atlantic Ocean is actually getting larger. At the floor here, where that crack is in the middle of the Atlantic, you have plates moving away from each other, and then lava kind of comes up where the plates split apart, and then it hits the water and kind of cools and forms lots of unusual steam vents there. And then in other places, you have plate being pushed into and being pushed under another one. That's the case with the Nazca plate being pushed under the South American plate. So this oceanic plate is denser than land or continental plates, so it's being pushed under and it's kind of pushing up the land, creating the Andes Mountains. And a similar thing is happening to at the Pacific, where the Indian plate is being pushed under the Eurasian plate, and that's pushing up and creating the Himalayan mountains. So the Himalayas are the tallest mountains in the world, and the Andes are the second tallest mountains in the world. And they're both taking place at convergent plate boundaries where one plate is being pushed under another and pushing up the land and creating mountain ranges. So this is life along the mid-ocean Atlantic ridge. You can see here there's lots of unusual ecosystems there. They have lots of odd plants and animals that live near these vents where you have the earth splitting apart from each other. You can see lava. That's literally where the crust is pulling apart. Lava is exposed, then it rapidly cools, and then the process continues as the floor slowly spreads and the Atlantic slowly grows. But these are just some of the unusual animals and plants that live along the mid-ocean ridge in the Atlantic. Here we have a map of different earthquakes and volcanoes. And as you can see here, the earthquakes in red and the volcanoes in yellow usually follow the edge of plates very closely. So where you have the edge of the Pacific plate, you have all these earthquakes because you have a convergent or divergent plate boundary where different pieces of the land are being pushed into each other. South America, where you have the Nazca plate being pushed under the South American plate, you have lots of earthquakes and volcanoes. So these usually follow the edge of plates, especially where you have two that are moving alongside each other, called a transform plate boundary, or being pushed into each other, one being pushed under the other, which is a convergent plate boundary. So the Pacific, especially the Pacific along Asia, has lots of volcanoes and earthquakes, and also along the western coast of South America and North America, there are many volcanoes and earthquakes as well. So this is a diagram of the Earth showing the tilt of the Earth and the rays from the sun hitting the Earth. The Earth tilts at a 23.5-degree angle. Mars tilts at about a 25-degree angle. Different planets have different tilts. Uranus is almost on its side. Venus is almost straight up, but it rotates in the other direction. So scientists consider it to be upside down at about a 179-degree angle. And as you see here, the sun heats up the earth, and places that get more direct sunlight are warmer. Those would be the tropics. Those are areas where the sun's rays hit more directly. So during the equinox, the sun's rays are right above the equator. And during the solstice and the summer solstice, they're above the Tropic of Cancer. And in the winter solstice, they're in the northern hemisphere, they're above the Tropic of Capricorn. So if you live within the tropics, it means that at some point during the year, the sun will be directly overhead and you're getting the sun. Water heats and cools more slowly than land. So land near water often is cooler. It has a moderating effect. So a maritime climate like Seattle or London will be cooler in the summer and warmer in the winter than someplace that's deep in the interior, like North or South Dakota or Mongolia or something like that. And from the further you are away from the ocean, the more extreme the temperatures are. My computer's been clicking a bit. Can everyone still see and hear me? It's been making some weird sounds. Audio just went out. Okay, can anyone hear me? Please type something if you can hear me. Okay, good. I've had some thunder too that might have been messing up with the presentation, but all right. So land near the ocean is more moderate than land that's far away in the interior of a continent. So San Francisco has a mild climate, Seattle, Portland, and then you get to deep in the interior, and then you have more temperature extremes. Another interesting climate control, something that can affect climate, is altitude and elevation. It's common for mountain ranges to have one side that's much wetter and another side that's drier. And this is true out west. If you look at the state of Washington, Seattle, where you're on the side of the ocean and you have the Cascade Mountain ranges, it gets a lot of rain, and then wind pushes moist air from the ocean up mountains. then it's pushed up and up and it gets cooler, and then it comes down on one side of the mountain as rain and snow. On the opposite side, it's a lot drier. So that's called the windward side, where you get the wind, and the leeward side, which is drier, where you're protected from the wind. And the leeward sides of mountains are almost always much drier than the other side. Yes, Amanda, do you have a question? If you have audio, you can turn it on or you can type it in.
Yeah, I was just gonna let you know we tried putting it in the chat, but your screen isn't sharing anymore.
Oh, how long? Okay. All right, 1 second here.
That's what I was gonna say too.
Okay, can you see now? You should see a mountain. Okay, can everyone see the mountain? Okay, good. All right, well, thank you for mentioning that. I guess I didn't see it in the chat. I was kind of looking at my notes. All right, we're back on track here. Let me go back one slide. These are some of the climate controls. Land near water is more moderate and cooler because the ocean heats slower and cools slower, so it has a moderating effect. And then land that is on the dry side of a mountain range is drier and gets less moisture than land that's on the ocean facing side. So that's true out west. Washington State's a good example of that. So one of the extreme versions of, I guess you call it the leeward side or the rain shadow side with the Atacama Desert. In South America, the Amazon is, of course, very wet, and the patterns are kind of reversed. So wind moves from the east towards the west there. It pushes up into the Andes Mountains. The Andes are very high, so it comes down on one side as rain that feeds the Amazon. And on the leeward side, the side protected from the moisture and the wind, you have the Atacama Desert in Bolivia and parts of Peru and Chile. And it's the driest desert in the world, excluding Antarctica. And it's also very high. So the fact that it is so high and so dry actually makes it an ideal environment for astronomy. The higher a telescope is or an array is, the less of the atmosphere it has to look through to see the stars. So it's an advantage to have astronomy equipment way, way up because there's less distortion. It's also good to have it far away from cities because there's less light pollution. And it's good to have it dry so you don't have clouds and moisture blocking the view. So really high, really dry, and really remote is ideal for observations related to astronomy. So this is the Atacama Large Millimeter Submillimeter Array, also known as ALMA. And it's a huge array of astronomical equipment. They're not really telescopes, you don't really look through them, but it collects information from space, and then it's analyzed by basically people from all over the world. So it's not just Bolivia, but it's funded with many different countries, and it's also used by many different countries. Here's some more information on different observatories. Kitt Peak Observatory, very large array, 7,000 feet. I think Keck Observatory is maybe in Hawaii, 14,000, and then Alma Observatory, 16,500 feet. So it's very high up there. All right, so there are lots of different climates, and a guy named Köppen came up with a climate classification system about 100 years ago that's still widely used today, where he breaks down the climate into five broad categories: A, B, C, D, and E climates. And then within those broad categories, he breaks it down a little further into three subcategories, and then there are even subcategories beyond that. If you really want to get into the weeds, they're about 28 to 29 classifications for climate in the Köppen system. A means wet climates, and these include tropical rainforests near the equator and tropical wet dry savannas or monsoon climates where it's wet part of the time and dry part of the time. Africa and Brazil have rainforests, the Congo and the Amazon basin, and then north and south of those rainforests you have savannas, open areas where it's rainy part of the time and dry part of the time, and there's lots of open grasslands and so on. And then as you move further towards the poles from the A climates, you get to the B climates, roughly 15 to 18 degrees latitude north and south. That's when the deserts start generally. And then these are drier climates where you have deserts, which are very dry, or steppes where you have some grass and vegetation, but not enough moisture to support trees. And then you get further away from the equator, you get into the C mid-latitude mild climates. There are many different subcategories of this. CA climates are fairly common. That's humid subtropical, much like the American Southeast, from Orlando up to Washington, D.C., and from Houston to roughly Oklahoma City. That large area would be considered humid subtropical. And then you also have CB marine west coast climates. Those are moderate climates that have the moderating effect of the ocean. London, Seattle, Portland would be examples of those. And then in the sea climates, you have Mediterranean, which are dry and warm in the summer and cool and drizzly in the winter, like California and like the Mediterranean. Then you get D climates that are continental. Those are only in the northern hemisphere in large land masses. That's what we're used to. We have warm summers, cool, often snowy winters, and major changes in temperature and a moderate amount of moisture, with no distinct dry season. And then you have E climates, which are tundras, and ice caps, which are way towards the poles or Latin or South America. And then highland H climates are really mountainous, complicated climates where the weather can change depending on where you are in elevation and in relation to, how high you are and where you. Lots of different microclimates kind of mixed together because of all the mountains. So parts of the Rockies are like that, parts of the Andes are like that, and the Himalayas and a few other places too. So complicated climates that are complicated by changes in elevation. So one major environmental issue among many is air pollution, also global warming and numerous other environmental issues we'll talk a little bit about. This is a picture of Beijing. In honor of the 70th anniversary of the end of World War II, Beijing shut down all their factories and cleared the air so they could have a nice parade. And then about 1 or 2 days later, they wanted to turn up the factories again, so they turned them on. And then coal-fired power plants that feed Beijing most of its energy are very dirty and polluting. And then you can see just within days, it went from nice clear blue skies, which is what it's like when you shut all the factories down, to what it's like most of the time where you have coal-fired power plants generating electricity and the factories up and running, and then it's a lot worse. So air pollution at a local level can be cut down significantly if you just cut down on its sources. So here we have a map of different bioregions in the world. This is a little bit like the Köppen classification system, but the Köppen system deals with temperature and moisture, while bioregions more or less deals with what grows there. It looks at the vegetation. So there's often a correlation between a Köppen system and a bioregion. Deserts are very similar. Deserts in the Köppen system are the same as deserts and grasslands here. And then there's some variation. In the Köppen system, temperate deciduous forests could be C climates or D climates. And so there's some variation there. But basically, this kind of looks at what kind of plants and animals grow in that region and classifies it that way. And you have deserts and grasslands, tropical savannas, tropical seasonal forests. Those are tropical savannas, tropical seasonal forests, and rainforests would all be A climates. Deserts and grasslands would be B climates. Mediterranean shrubs and woodlands would be a type of C climate. Temperate deciduous forests could be C or D climates, and then evergreens would be some of the colder D climates. So evergreens are where you have coniferous forests, where you have pine trees, and temperate deciduous forests like Michigan up till about the UP is like we have in Jackson, where you have trees that drop their leaves during the winter and then they come back during the summer. So these are different bioregions of the world, and they also have ice and tundra. So there's some overlap between specific bioregions and specific Köppen classification systems. So these are some more bioregions in detail. Rainforests only cover about 7% of the world's landmass, so that's not actually that much, and that's just the landmass. So it's, when considering that about 70% of the world is oceans and water, that's a fairly small percentage. They have rain all year round, usually about 70 to 150 inches on average. They are the most diverse bioregions in the world. They hold the most variety of plants and animals, especially when you consider insects. And they're also very vulnerable to deforestation. Lots of Amazon rainforests are being cut to make way for soybeans and corn and cattle. And lots of rainforests in Southeast Asia are being cut to make way for palm oil plantations that have lots of different purposes. So they're very vulnerable. They need to be protected. If they are protected, they have a chance of becoming maybe ecotourism or something like that, but very diverse and very vulnerable and relatively small part of the land in the world. Tropical savannas and tropical seasonal forests. This picture on the bottom left is of Brazil. Parts of Africa look similar to it. Wide open areas with lots of grasslands, often large herding animals with a distinct rainy season and dry season. And then on the top right, tropical seasonal forests are found in parts of India where they have trees that drop their leaves during the dry season, kind of like they would here during the winter because there's not enough water to support them, and then they come back. So where you have monsoon seasons in parts of Bangladesh and India, you'll often have tropical seasonal forests. Deserts, these are areas that generally receive 10 inches of rain or less per year. Sometimes a desert area can get a little more than that, sometimes less, but generally on average, 10 inches or less per year is considered a desert. If it gets a little more than 10, it might be considered a steppe or a prairie or kind of a transition between them. And the Sahara Desert is pictured on the left there. That's the largest non-polar desert in the world, excluding Antarctica. And on the bottom right is, I believe, in Arizona. Cacti are rare outside of the Americas. Almost all cactus are found in North and South America. Africa, Asia, the Middle East have very few cacti, so nothing like we have here. So if you've ever seen Westerns and you don't see any cacti in them, it was probably filmed in Italy. It was probably a spaghetti Western, not a real one. So prairies and steppes, these are areas that have enough rainfall to support grass, but not enough to support large forests. And lots of the American West would be considered prairie. It's hard to tell because now a lot of that prairie has been turned into productive farmland. So much of the natural prairie land has been turned into cornfields and soybeans. But if it was left in its natural state, Nebraska, large portions of Illinois, and much of the north central part of the US and Canada would have long grass and rain part of the year, enough to support grass, not necessarily enough rain to support forests. Steppes are like prairies, but usually colder, drier, with shorter, stumpier grass. Mongolia would be an example of a steppe. Much of Central Asia would have a steppe. And the American West, which gets a little more moisture, would be a prairie with longer grass and slightly warmer temperatures. Mediterranean shrubs and woodlands, these are Greece and Italy, parts of California, and much of the American Southwest along the Pacific. These are places that have more than 10 inches of rain per year, so they're not considered a desert, but they have a long, dry summer and a cool, drizzly winter. The Mediterranean climate is the only climate that has a dry summer and a wet winter. Most climates, that's reversed. Usually it's wetter in the summer and drier in the winter. So Mediterranean climates is the only one that has dry summers and wet winters. And temperate deciduous forests, this would be the American West from, again, northern Florida up through New England. It could be warmer in a C climate, it could be colder in a D climate, but these are big forests with oaks and maples that drop their leaves during the winter, and then they come back during the summer. New England, this is a picture of New England deciduous forest. It looks like it could be in Michigan. These are common in North America and Europe, and some of them have been cleared because some of these have rich soils, but many of these forests remain too. And then evergreen forests. These are areas that receive around 40 inches of rain, but are a little too cold to support the deciduous trees. Deciduous trees need warmer temperatures. They need more light. So if you get north of the deciduous trees, and when you get to the Upper Peninsula and southern parts of Canada, you transition away from hardwoods to these pines and coniferous trees. And these trees do better in colder environments and drier environments. They keep their needles all year round. They don't drop them. That's hence the term evergreen. And in northern Canada, they're called boreal forests or evergreen forests. And in Russia, the similar climate is called the taiga. So these are huge land masses with lots of pine trees and coniferous trees. And it's the largest land biome in the world. So these are bigger than deserts, bigger than deciduous trees. They're huge portions of our land on Earth, especially in Canada and Eurasia, that are boreal forests or taigas. Isle Royale is an example of what would be a boreal forest. It's kind of on the transition between deciduous forest and boreal forests, but I went there once a long time ago. It was really cool. They have wolves. They almost they got to the island in the 40s, then they almost went extinct, so new wolves were brought in, and now there's a pack of about 20 or so. And there are moose on the island, and it's really pretty, very remote, and a good example of a boreal forest or coniferous forest. And then tundra, as you get further north of the boreal forests, then you get to where it's too cold to support trees. And then you have tundras, which are, they're alpine tundras, which are really high up in mountains and can be anywhere. But then the Arctic tundra is where you just have vast swaths of very short grass or lichen and not many animals, maybe a few hares or rodents here and there and a few wolves, but vast amounts of methane are stored in the soils of these areas. So these are areas that are north beyond the boreal forest, but before you get to the ice of the Arctic, you have these large, very vacant areas of tundra, very little vegetation and relatively little wildlife. And then, of course, Antarctica and Greenland is ice, and these are areas where you just have ice covering it all year round. So those are ice caps, and those are rapidly melting in Greenland and Iceland. So a little bit about North America. The United States and Canada is culturally diverse and very wealthy when it comes to industry and finance and so on. It has, by most accounts, a post-industrial economy, although we still do make many things. And this, of course, is chapter 3, the first region that we study. This specific region only includes 2 countries. Most have a lot more than that. And Mexico geographically is considered part of North America, but our book culturally and economically considers it part of Latin America. So even though it's part of North America, it's talked about in a different chapter. And this is the climate and pattern vegetation. This is the Köppen system kind of imposed on the US and Canada. Again, C climates transitioning into D climates, transitioning into colder versions of D climates, and then into the E climates. And then as you get out west, past roughly the 50th line of latitude, when you get west of the 50th line of longitude, it gets significantly drier. That's when the kind of deserts and steppes start. But there isn't necessarily a stark transition from one to the other like it looks like on this map. It's sort of a slow transition from a CFA to a DFA to a DFB. Jackson, Michigan would be right on the edge of what's considered a DFA, which is humid continental warm summer, and DFB, which is humid continental cool summer. So according to this map, we're just in the warm summer, but then you travel 2 or 3 hours up north towards Mackinac, and then it gets a little cooler, and that's considered a different Köppen subgenre. So those are the different Köppen classification systems of North America. So North America is an area that's been heavily modified and changed, and not just in obvious ways. We think of course, cars and parking lots and streets and sprawl and suburbs, but also places that used to be prairie have been converted into cornfields and converted into wheat and converted into soybeans. So that's also a form of human conversion. So much of North America has been changed and transformed into things that we think of as more important and productive and more industrial and more useful places to raise cows and grow food and have cities and so on. Areas that are protected like national parks and national forests are a remnant of what North America was before it was industrialized and changed. So one major issue in North America, a big environmental issue that's especially bad here, is the urban heat island effect. Because so many of our cities are car-centric and sprawling with very little shade and huge freeways, cities like Atlanta or Houston, Los Angeles, Phoenix, and some of the southern Sunbelt cities especially can get really hot in the summer. They're often very long commutes, cars stuck in traffic, and having lots of concrete and building in cars can lead to significant increases in average temperature compared to farmland or wilderness or forests on the outskirts beyond the urban area. And you can see here on the right, the map shows temperature in red, and then in Atlanta, in the downtown area and suburbs along the freeways, it's a lot hotter than just a couple miles out into the woods and forests and farmlands and so on. So this is a major issue in many American cities. Phoenix has had several days above 110 degrees, and it's naturally hot, and that's part of the issue, but it's also that this massive sprawling car-centric area has so little shade, so much concrete, so many roads and buildings that heats up the urban area more than it would be if they had vegetation or forests or trees or more shade. So there have been some improvements, kind of reclaiming old industrial areas and abandoned areas to add more green space and add more pedestrian-friendly areas. In Atlanta, there was an abandoned railway that went around the outskirts of downtown Atlanta that is currently in the process of being converted into a pedestrian hiking and biking path that will form a loop around the entire city. They're about 2/3 of the way done. So that's really kind of interesting. And there are a lot of other different projects like that throughout the country. This is more information on the Atlanta Beltline, it's called, this old abandoned railway that's being converted into this massive walking path, this big linear park. It's been a huge success. One complaint is that it's drawing a lot of attention and industry and housing along it, which is great, but that's also making the rent skyrocket anywhere within walking distance of the Beltline. Rent is going up, and old, cheaper buildings are being torn down to make room for new residential buildings. So it's attracting gentrification. That's a negative thing, but it's basically a real nice feature to have in Atlanta and in other cities. These are other cities doing similar things. On the top left is New York's High Line. This was an abandoned elevated train track that's been converted into a path and a linear park. Chicago added a linear park and bike path along one of its neighborhoods. I think it's called the 602. On the bottom left is the DeQuinder Cut in Detroit. This was also an abandoned railway that was converted into a walking and biking path. It's only about 1.5 miles long, but it's through kind of different neighborhoods of Detroit, and that's been very successful. And on the bottom right, Indianapolis took a 4-lane road, made it into a 3-lane road, and then made one of their lanes into this pedestrian biking and hiking path called the Heritage Trail. So some cities have tried to make cities more livable by making them more green and pedestrian friendly and less car centric. Here are some of the major environmental issues in North America. You can see acid rain is not as big of a problem as it was, but it's still a major problem. Potential droughts in the Southwest are a serious issue, and you can look at this in your book for a little more information. But these are just some of the major environmental issues affecting North America. And there's been a shift to some degree in North America away from dirtier forms of energy like coal towards cleaner ones like renewable wind, solar, and so on. One of the biggest increases, however, has been in natural gas. And although natural gas is a little better than coal in most regards, it's still considered a fossil fuel, and it still has its drawbacks. So although coal's on the decline, it's mostly on the decline because natural gas is replacing it. Wind and solar and nuclear are important and growing, but not as large at the moment as petroleum or natural gas. Here's a little more information on hydroelectric, solar, wind, and geothermal. You probably all know solar and wind fairly well. Hydroelectric is like the Hoover Dam. That picture was taken years ago. Now the reservoir behind it, the water is way, way lower than it was then. If you've seen contemporary pictures of it, the lake it's about half as much water as it was in that picture. And geothermal energy is basically taking the Earth's heat and turning it into steam and using that to turn turbines to generate electricity. There are a few geothermal plants in the US. Iceland gets about half of its energy from geothermal. Italy and New Zealand have some geothermal plants as well. So a lot of potential that hasn't been fully realized. So modern spatial demographic patterns of North America. There are a lot of big cities on the Northeast and especially along the Pacific. And then the population drops significantly once you get to roughly the halfway point, roughly the 50th line of longitude, and then it gets drier. And you can see here, it almost splits the country in half, which more population density to the east and far less to the west, with some exceptions, Salt Lake City, Denver, and so on. But most of the population on the east and the west coast, with some large centers, some large areas in the west. This is interesting. This is a picture of the US at night. It looks very similar to a map that shows population density. These glowing areas are major cities. Detroit can be easily seen on the southeast part of Michigan. Minneapolis, St. Paul is kind of in the north central part. You can see LA and so on. There's a large glowing area in a rural part of North Dakota. There's no major city there, but there's a lot of fracking. There are so many gas wells lighting off flames because of excess natural gas that you can actually see them from space. So most of these are cities. Some of them are wells looking for natural gas. So here's two different population pyramids of two different states in Michigan and in the US. Iowa, you can see, is a little narrower at the base. Texas, which has a younger population and more immigrants, is wider at the base and a little narrower at the top. So even within one country, there can be significant variations in population and how population is spread out. And this is where the population of the US has been moving over time. This shows the mean center of population for the continental United States. So in 1790, it was around a little bit north of Washington, D.C. And then more and more people started moving west. The mean center population of the country started to move west by 1920. It was in Indiana. And then when air conditioning was invented after World War II, you can see it starts to dip southward, not just westward. And now it's gotten further and further south. And as of 2010, South Central Missouri is considered the mean center of the population for the US. So that means there are still quite a few people living out east, but more and more people and more cities have been growing in the south and the west, which has been pulling the mean center population towards the south and west. So after World War II, there's been a big explosion in freeways and suburbs, and air conditioning made hotter climates more livable. So here you have, I believe that's Houston, and on the bottom right, you have an interesting massive subdivision called the Villages near Orlando, Florida. This is basically a series of retirement communities that kind of form their own city, where people often drive around on go-karts, and a lot of the people are from Ohio and Michigan, where they wanted to move down south to get away from the cold weather. So they moved to planned communities in Florida or elsewhere where it's warmer. And that's one of the reasons why southern states' population have been growing significantly recently as people leave colder northern states for warmer southern states, especially to retire. Here are some settlement patterns. We'll try to wrap this up in the next few minutes. But in Europe, settlement patterns were often haphazard, while in North America, our forefathers were able to plan states in a logical grid-like formation, breaking down states into counties and counties into townships, and those into 1 mile blocks and those into quarter sections. So if you look at the US from space or the sky, you'll often see kind of rectangular blocky formations, while in Europe, it's often much more haphazard where land begins and ends and where different plots of land begin. So the US from the sky will often look like a quilt of different sections kind of sewn together with different kind of land uses. So the US is multicultural and becoming more diverse. As of 2030, it's estimated that about 25% of the 23% will be Latino, about 57% will be white, 13% roughly African American, and 7% Pacific Islander or Asian. This doesn't really take into consideration mixed race persons. It probably should. And then it's estimated by 2050, about half or slightly less than half of the population will be white, and there'll be a larger Latino and Asian population especially. So demographics in North America are changing, and the Latino population is growing largely because of immigration. So the US is very influential globally. English is spoken in many parts of the world. English is taught in China at the age of starting in the 3rd grade. And this has led to some English and Spanish mixing and Chinese and English mixing into informal languages that are kind of a hybrid of both, or poorly translated signs. You can see here, these are signs in English in Asian countries: deformed person exclusive use. They mean this is handicapped accessible. Again, kind of lost in translation. And to abuse plastic bag, please pay money each $2. I think that means it's a $2 fine if you litter a plastic bag. So it's kind of interesting. It's difficult to translate English into Chinese or Japanese because the languages are so different. So sometimes it doesn't translate well. Here are some that are even worse. Hand grenade. Someone looked at a fire extinguisher, thought it was a hand grenade. And execution in progress. I don't know what that's about. It looks like someone's cleaning the floor. So they say execution in progress. So geopolitical framework. These are some of the political issues affecting North America. Undocumented immigration, commercial lumbering is a major issue along the US-Canadian border. Environmental issues related to working with limited natural resources and water and rivers and so on. So you can read a little bit more in your book if you want more information on this, but these are some of the geopolitical issues facing North and South America, facing North America, Canada, and the United States. So on the top left is a picture of the US-Canadian border in the Pacific Northwest. There's a long open border where they just kind of cut the trees for about 10 meters, and that's the border. And if you contrast that to large portions of the US-Mexican border where there's a barrier wall, the US is on the right. They, as you can see, look very different. So there's not a lot of immigration from Canada sneaking into the US from the northern border, but in the southern border, many people, often from Central America, not necessarily from Canada, are trying to enter the country for various reasons, seeking, safety. They might have had environmental issues or problems in their country, or political instability, or crime, or unemployment. So many people from the Western Hemisphere all over really are trying to migrate to the US for various reasons. Your book talks about push factors and pull factors related to immigration. So an abundance of resources. The US has lots of industry. This is interesting. It kind of shows how land is used, irrigated agriculture, livestock ranching, general farming, and so on. So as you can see, a lot of Michigan is dedicated to dairy farming. That could be cows, or it could be corn that's raised to feed cows, or soybeans that are used to feed cows. These are major industrial areas you can see in the slash marks. So this is kind of a breakdown of what land is often used for in the United States. And enduring social issues, wealth and poverty is a major issue in North America, as it is everywhere. A fairly recent issue that just seems to be getting worse is affordable housing. We're not building enough homes. Home prices keep going up and up and up, and we're just not building enough homes to keep up with demand. Interest rates are going up, and that's making homes more expensive. So a lot of people are struggling to pay rent and buy a home. Maybe some of you know how difficult that can be. And healthcare for the aging is a major issue. And also recently, declining birth rate in the United States. Before the Great Recession in 2007, roughly, the birth rate was about 2.1 kids born to a typical woman in the United States. Now that's kind of declined, and it's about 1.6 to 1.7. So without immigration, the US population would be level or even starting to decline, not as extreme as Korea or Japan. But because of immigration, we're still growing slowly. But the declining birth rate is a major issue that's become a greater issue in the last few years or so. So if anyone has any questions, you can send something in chat, or you can ask if you have a microphone. Otherwise, next week we'll do something similar to this Wednesday evening, dealing with chapter 4 and chapter 6. And then we'll cover 2 chapters basically per Wednesday for the remainder of the semester. So does anyone have any questions you'd like to type in or say through the microphone? All right, well, if there aren't any questions, thank you for joining me. I'll try posting this so people who weren't able to join us can see, but I've had some issues with that in the past. But keep up the good work, and I will see you all next week.